So today we discuss the particle nature of light. Okay. So actually today is the last class of dual nature radiation and matter. Okay. So here we discuss particle nature of light. The last part, particle nature of light. Okay. So previous class we build the concept of photoelectric effect. Okay. So what is photoelectric effect? We know that. Okay. And this photoelectric effect gives the evidence that some strange fact that light also behave as some tiny particle. Okay. So photoelectric effect gave us strange fact light. Okay. So light also, this means light behave as, okay, light behave as some tiny particle, very tiny, very tiny actually. There's a very tiny particle, and this very tiny particle is called quanta. Okay, and this tiny particle is called quanta, or call a packet of energy, or call packet of energy. Okay, actually build that concept, okay, from photoelectric effect, how the photoelectric effect works, and how we gave that a proposal is that a light behave as a quanta or packets of energy. Okay, so here is the light quantum, okay, associated with a momentum, and now you know that the light quantum, mainly light quantum associated with momentum. If it is a quantum, is a tiny particle, so there is some momentum. Okay, so there is some momentum concept here. Okay, and that momentum p, that is equal to h nu by c. Okay, here is h is a Planck's constant. Okay, and you know that the Planck's constant h, and nu is the frequency, and c is the speed of light. Right, we know that all better. Okay, so there's a momentum, and then the energy and momentum of light quantum associated with the particle is called photon. So what is photon? Here we establish the definition of photon is the energy, okay, and the energy and momentum, okay, the light quanta, mainly in light quanta associated, okay, with particle and very tiny particle. Actually it's a very tiny particle, is called photon. This tiny particle is called photon. Okay, so here some other experiment established that light as a some tiny particle photon is that a Compton effect, scattering of X-ray. Okay, in 1924 experiment of A.H. Compton, scientist, effect of quantum effect. Okay, that is scattering of electron. Okay, clear. That's the basic. Actually, the quantum effect, these are not in our syllabus, so that's the excluding part. So actually do not discuss that what is the quantum effect, but in basic idea there are some other experiment to establish the concept is that light is a tiny particle and is called a photon, light energy obviously. The summary of photon or picture radiation is that very little discussion here. The summary is that, okay, so EM radiation, actually this summary, actually dual nature radiation came from EM wave, okay, electromagnetic wave. That's the main important part in our class 12 physics or JEE NEET. Okay, the main important part, electromagnetic waves radiation here. So the summary is the first part we discussed The radiation of matter, mainly. Here we discuss the radiation of matter, okay, and that it behaves if it is made up of tiny particle. It is a matter, it behaves radiation of tiny particle, radiation of tiny particle is called photons. Okay, number two, very important. Okay, and that each photon, the energy, so actually there is the energy. Okay, light energy is called photon. Okay, meaning the light energy, light as it is the energy, so light energy is photon. Okay, and this is light energy, each photon. Okay, each photon have some energy, that is E, that is equal to h nu. We know that the equation, Einstein equation. And the momentum, so momentum get from here, P equal to h nu by c, and get a momentum h nu by c. That's the momentum. Okay, so here photon have energy. The photon energy is equal to h nu, and the momentum equal to h nu by c. Okay, and if you see that all photon energy, okay, now if you consider that all photon energy and all momentum concept here, the each photon of this is all, so there is a multiple be added here, some added be added, actually they obey the superposition principle. Okay, so here is some fact here discussion. So if that is equal to time period t, that is equal to lambda wavelength here, that is a distance by speed. Okay, and here that time period 1 by time period means 1 by frequency, so here frequency is a nu, that is lambda by c. Okay, clear? So now the nu, that is equal to c by lambda concept here. So now if you write down the E, that is equal to h nu. Okay, so h and nu equal to c by lambda, speed of light by wavelength. Okay, so c by lambda, and that's the concept. Okay, that's the energy E equal to hc by lambda, and here comes from P. Okay, so P comes from P equal to h nu by c, and here h nu by c, and if I see that nu by c, that is equal to 1 by lambda. So let nu by c equal to 1 by lambda, so get p equal to h by lambda. Get another expression, that is p equal to h by lambda. The p here is a momentum, h is a Planck's constant, and lambda is a wavelength. Okay, so here the important factors, okay, from discussion here. So if they increase the number of photon, okay, the theory, if the from photoelectric radiation, if I increase the number of photons, so number of photons means if so here same diagram, photoelectric and the quartz window, there is some emitter plate and here is some collector plate, there is some potential here. Okay, so if the energy released from here, and if a light energy falls on here, okay, and the increase the number of photon. If you increase the light energy, if they increase the light energy means the number of photon per second also increase. Okay, if you increasing the number of photon, if increasing number of photon, okay, per second, obviously per second, photon releasing per second, so that if photon is increased, the light energy also increasing, the crossing the given area, so here is some area, crossing this electron jump from this area and reach that collector plate, there is some area here, there is some area here, and crossing some area, crossing some given area with each photon having the same energy, with each photon having same energy. Okay, and this photon energy independent of intensity. The key point is the photon energy. Okay, so the photon energy is independent of intensity of incident radiation. Intensity of incident radiation. It means there is incident radiation, there is a UV ray here. Okay, clear the concept. So the UV ray. So here and next part, the photon. So number is 3 here. Next part is 3. Okay. So if here we discuss the photon are electrically neutral. Photon are electrically neutral. Okay. So don't be confused here. Okay. Electron are electrically negative particles, but photon are electrically neutral. Okay. And deflected by the electric and magnetic field. And deflected by electric and magnetic field. E and B field, deflected by E and B field. Okay. And number 4, in a photon particle collision. Okay, so important, very important here. So in photon and particle collision, so photon and particle, if the collision to here, photon and particle, these two collision, such as the call a photon and electron collision, called photon and electron collision here. Okay, the total energy and total momentum are constant. Okay, if a photon and light energy and particle means an electron are collide, the total energy, because the energy is conserved, we know that total energy and momentum be conserved. Photon, so number of photon, okay, may not be same. Keep in mind, may not be same. Photon number a little bit varied. Okay, may not be same. Before the collision, so some photon be absorbed and some photon be created. Okay, in collision, some photon be absorbed and some are created. Okay, that's very important. There is a summary of the picture of the EM radiation. Okay, so here we jump to our next part, that is the wave nature of matter. That's very important. Discuss wave nature of matter. Wave nature of matter. Wave nature of matter. So here comes some de Broglie concept. So de Broglie, a scientist, actually the proposal he proposed that is a wave nature. Okay, wave nature, mainly the actual dual nature of matter. Okay, so he proposed that the wave particle duality is de Broglie. Okay, and she's a French physicist, de Broglie, in 1924. He proposed that is a dual nature. Okay, de Broglie. Okay, de Broglie that proposed the dual nature. Dual nature. Okay, mainly the dual nature is that a wave and particle nature. The dual means here wave nature and there is some particle nature. Okay, when you say that is interference, diffraction, polarization, these are the wave nature of light. Light is an electromagnetic wave, and if you jump to the photoelectric effect, we treat it as a particle nature, and this particle nature comes from a quantum. Okay, and the quanta, very small particle, that's the particle nature. So there is a wave nature and particle nature. Okay, and the reason that mainly the concept is that the moving particle. Okay, if a charged particle are moving here, the hypothesis, the de Broglie mainly hypothesis is the proposed that the moving particle of matter should be display wave-like properties under some suitable condition. And here is some reason that the nature of the symmetrical and that the basic of two physical entities. And these two physical entities is our matter and energy. The most of the symmetrical properties of character is the radiation in dual aspect, and you should be the matter and also the energy. The de Broglie proposed the wavelength associated the particle momentum with P. Okay, so here the mainly the two picture is that one is the electron and other is the photon picture. The dual picture is like that, electron and photon. Okay, and particle nature is the wave nature. Okay, the moving particle. Okay, if the concept moving particle, here you see that in photoelectric effect the particle electron are moving. Okay, moving from emitter plate to collector plate. Okay, in that direction, if the electric field in that direction and the electron is moving in that direction. Okay, so the moving particle matter should display like a wave-like properties under some suitable condition. Okay, so moving particle show some wave properties, but here some condition. Here some condition may be applied here, may or may not be, but actually the condition be applied. Condition be not may not be, but condition is to be applied here. Not okay. Which condition be applied? That here reason that the concept is that in sugar condition, the reason is that the nature of the symmetrical and that the two basic physical entities. The condition, why the condition is not may, there's a but must be the condition be applied. Okay, so there is some two physical entities and two physical entity. And what is these two physical entity? That is the energy and matter. These two physical entities, energy and matter, and must have a symmetrical. Okay, we consider is the must be the symmetrical character, and these are the symmetrical character. The symmetrical character. If the radiation dual aspect should matter, and radiation obviously that not actually, but we discuss this is the particle nature and sometimes we discuss wave nature, but there is some dual nature obviously. So if a dual nature, okay, radiation matter, de Broglie proposed that there is a wavelength associated with the particle momentum, and here I discuss that the wavelength. Okay, here I discuss the wavelength, and these wavelength associated with the particle of momentum. So lambda here, the lambda associated with particle of momentum, particle of momentum. So here the de Broglie concept is that P equal to, you know, that is h by lambda, and lambda equal to h by P. That's the de Broglie hypothesis. And here the h, P equal to mass into velocity. Okay, and there's a de Broglie relation. Okay, the momentum. Okay, and the matter wave is the called de Broglie wavelength. Okay, and the matter wave here is some matter wave is called de Broglie wave. Wavelength. Okay, there's a matter wavelength. Okay, so de Broglie, that's the de Broglie relation, and that is P equal to, you know, the concept that is equal to h nu by c, and here we get from h by P equal to lambda. So here P by H equal to nu by C. If I inverse that here, H by P equal to C, that is equal, H by P, that is equal to nu by C, and nu by C, that is equal to lambda. So H by P, that is equal to lambda. We prove that de Broglie relation or wavelength, okay, from that concept. So de Broglie wavelength of photon, okay, is equal to the wavelength of the electromagnetic radiation. So here that lambda associated with the de Broglie, the concept is that, so if de Broglie proposal, okay, the wavelength of the photon, okay, if the lambda is a wavelength of photon, okay, is that equal to the wavelength of electromagnetic radiation, is equal to wavelength of EM radiation, okay, and the photon, okay, the photon, with the photon is the quantum energy and momentum, and photon is a quantum energy, and if the energy, there is a momentum here, and there is a momentum, okay, and the lambda, another concept, that is a lambda, okay, lambda is a smaller, if the lambda is smaller for heavier particle, heavier particles, and heavier particles means mass is large, is called a heavier particle, okay, and for more energetic particle also V, or same case, or more energetic particle, more energetic particle, get a more lambda here, okay, minimum lambda here. Okay, first there is some take an example, and if you put a mass value here, suppose you say that calculate for mass given, that is 9.1 into 10 to the minus 31 kg, and that is mass, and if that is at Planck's constant, if H, that is equal to 6.6 into 10 to the minus 34 joules second, and that is a mass, and that is speed of light, that is equal to 3 into 10 to the power 8 meter per second, okay. So here put some value here, mass h and velocity v, and lambda equal to h by mv, and here you put that wavelength, that is h, Planck's constant, mass of the electron, and speed of mass of the electron, and speed of light, and if you get a value of lambda, that's a very easy concept. And if you know the velocity, a mass into velocity, you get a momentum, okay, and you put momentum value here, we calculate that lambda wavelength. That's a very easy concept. If you want to calculate, and some mathematics here, with the help of calculator, you can calculate and put that value in comment section, okay. So that's the today's our class, okay, end of the class, and we complete the chapter of dual nature of radiation and matter. That's very important in board exam. There is some conceptual question, you get 1 or 2 marks question, okay. There is no such derivation here, but you have study this chapter, read the chapter, and if you have any doubt, please ask in comment section. But this chapter is very important, okay. These are actually the quantum mechanics chapter, and if for further studies in physics, and you get that, or chemistry, you get quantum chemistry and quantum physics, you know that concept or more detail about that, okay. That's not a very vast actually the topic here discussion, but here it just we discuss the 0.5% of that, okay. So that's the dual nature of radiation matter. That's our class 12 syllabus, okay. If you have any doubt, please ask in comment section, okay. Today end the class here. Thank you.